This video is on quadratic applications on projectiles. We're going to do a couple more examples. So word problem says Robert threw a rock off a bridge into the river. The distance from the rock to the river is modeled by the equation h equals negative 16t squared minus 16t plus 60, where h is the height in feet and t is the time in seconds. What was the height of the rock half a second after being thrown? So let's draw a picture. So we know that Robert is standing on a bridge and is being thrown off the bridge into the river. So height, we know it's not really going to go underneath the ground. It might go in the water, so it might go underneath the water, but we're really going to focus on the top. And then time, we know we can't go backwards in time, so we're going to focus specifically on the first quadrant. So time is really our x, so our time is our x-axis, and our height is our y-axis. Our y-intercept is 0, 60. That means that Robert is actually standing on a 60-foot bridge. So we know it's going to start about here. It's above the 0, 0. This is at 60 feet because our y-intercept is 0, 60. And we know that the path of the rock, we know Robert's throwing it up into the air, and then it's going to come back down and then land into the water. So the question is asking, what was the height? So we want the y value of the rock half a second after being thrown. So if it's half a second, it's probably going to be about right in here. So we want the height when it's close to being about here. So half a second. So what does that mean? We have our equation. We want the height, so we do not have the h value. What was the height? This is our h. H is our question mark of the rock half a second after being thrown. Half a second, that's time. So time is equal to a half of a second. So 0.5 basically. So write the equation that you're trying to solve. So if we go with this question, we don't have h. So if we're gonna plug in h as h because we don't know it. But we do know the time. So all we have to do is plug the time in for the h. So we have negative 16. Our time is half a second. So I'm going to put 0 and 5/10 squared minus 16 times 0 and 5/10 and then plus 60. That's all we're doing. So when we plug this in, if we plug into our calculator, we get negative 16 parentheses 0.5 close parentheses squared minus 16 parentheses 0.5 close parentheses and then plus 60. We get 48. So the height after half a second is actually going to be equal to 48. Now if we look back at our picture, I put that half a second might be here. So I was overestimating Robert's ability to throw. So after he's already thrown it from 60 feet, so he's actually throwing it. So about half a second, it's actually going to be about here, 48 feet in the air. This is really where it's going to be because it's below the 60 feet. So his maximum height took a lot less time to throw. He might not have been able to throw very well, so it's going to end up here. This was a potential maybe right here, but actually it took half a second to get here. That tells us that it doesn't take long for it to hit the ground. So to answer the question, after half a second, the rock is at 48 feet above the ground or above the water, above the river. So it does not take long for the actual rock to hit the river because it wasn't a very hard throw. Next one, during a game of golf, Kaylee hits her ball out of a sand trap. So before we continue, it's out of a sand trap. A sand trap is actually underneath the ground, so she has to get it up onto the green, and then it's going to keep going to go to the green. So the height of the golf ball is modeled by this equation, h equals negative 16t squared plus 20t minus 4. And that tells you your y-intercept, so you know that it's actually underneath the ground at the beginning, where h is the height in feet and t is the time in seconds, since the ball was hit. Find how long it takes Kaylee's golf ball to hit the ground. So let's draw a picture of this. So on this one, the height, we actually know that her ball is underneath the ground already because it's at 0, -4. So we do have a little bit of the negative y-axis, but we know that we will not have a negative x-axis. So we still have time here and height. So it's actually starting at -4. This is where she's starting from, at -4 feet. And the height, the path of the ball, she's going to hit it out of the sand trap. It's going to go up, and then it's going to come back down until it hits on the green where she wants it to go. So let's make sure we understand the question. It says how long it takes Kaylee's golf ball to hit the ground. So we want it to hit the ground. That's where we're looking for. Now, Kaylee's golf ball, when it comes out, it's going to have an x-intercept here, but this is not the one we want. We actually want to know, after it comes out of the trap, out of the sand trap, as it's going, how long does it take to finally hit the ground on the green where she wants it? This is our question. So we have to write an equation for what we want to solve. If we're finding this value, we're given this equation. We want to find how long. So this is time. We don't know that. So t is our question for it to hit the ground. That means if t is our question, we have to have h. If it's on the ground, the height is 0 because that's our axis. So the equation we're going to write is 0 equals -16t squared plus 20t minus 4. So in order to solve this is just it's a quadratic equation. We can solve this using factoring, quadratic formula, completing the square, graphing. We just want to solve this. Now, we will end up having 2 answers, and it makes sense that we're going to have 2 answers, and they should both be positive, but we've got to remember which one we want. This one will have a lower positive value. That's how long it takes for it to get out of the sand trap, and this one is the one it takes for it to all the way hit the green, which is what we want. So if we write this equation, we have -16t squared plus 20t minus 4 equals 0. All of these are actually divisible by 4. So 4 is our smallest number, and we want a positive a value, so our GCF is -4, so let's factor that out. So we have -4 parentheses, positive 4t squared minus 5t plus 1 is equal to 0. So let's see if this will factor further. So -4 parentheses, 2 sets of parentheses, is equal to 0. So we have 1 and 4, so I'm going to do this in pencil because I'm going to use guess and check. We have 1 and 4 and 2 and 2. So we have 2t and 2t. Then we have 1 and 1. They both have to be negative. So we have -2 and -2, which will not give us a -5. So that is not the ones we want to use. So if I switch my ones, it won't help us, so I have to switch my front terms. So I'm going to have 1t and 4t. So I have -4 and -1, which gives us a -5. So this is the correct factored form. So now we just want to solve. This term right here does not have a t on it, so I focus solely on these. I have t minus 1 equals 0, and 4t minus 1 equals 0. So to solve, t equals a positive 1, and t equals a positive 1/4. Now again, the question is asking when will it hit the ground. So it takes 1/4 of a second to get out of the trap. So I'm going to write that. It takes 1/4 of a second to get out of the sand trap. And then it takes 1 second to hit the ground. So the question was asking when does it hit the ground, so this is the one we want. This is one I'm going to highlight. But to understand what that 1/4 meant, because it was an answer that you had gotten, it will take 1/4 of a second to get out of the sand trap. So it is important to know which question you're answering. All right, this last one, it says the height of a rock thrown off a cliff can be modeled by the equation h equals -16t squared minus 8t plus 120, where h is the height in feet and t is time in seconds. How long does it take the rock to reach the ground? So again, this time it is hitting the ground. So when we have our picture, we have just the first quadrant. We have time and height. And it's starting at the cliff at 120 feet. Somewhere up here, this is 120 feet. So again, the person throwing this might be like Robert from this first example where he doesn't have a very good throw. But it could still follow this path where it's going up and then coming back down. And the question is, how long does it take the rock to reach the ground? So we want to know, when does it reach here? This is our question. So how long means time, means we don't know that. So time is our question. And to reach the ground, that means, if we don't have t, we have to have h. To hit the ground, your height is 0. So the equation we're going to have is 0 equals -16t squared minus 8t plus 120. So we're going to see if we can factor this. So if I write out -16t squared minus 8t plus 120 equals 0. My GCF, I look at 8, 16 can be divided by 8, and 120 can be divided by 8. So my GCF will be the -8. So we're going to have -8, parentheses, we're going to have a positive 2t squared plus 1t minus 15, now equal to 0. So we're going to have -8, parenthesis, 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 parenthesis. So we're going to start with 1t and 2t. I want to end up getting a t in this, just a 1 value of t. So we have 1 and 15, and then 3 and 5. So I'm going to put my 3 in here, and then my 5 in here to check it. This will give me a 6, and this will give me a 5. 6 minus 5 gives me the 1. So I want 6 minus 5. So I know that has to be the negative, and this one will have to be the positive. And these are equal to 0 still. So then I take the factors. I have 1t plus 3 has to be equal to 0, and then 2t minus 5 has to be equal to 0. My two solutions are t equals -3, and then t equals positive 5 over 2, which is equal to 2.5. So if we're talking about time, let's convert it to a decimal. So it takes, we know it can't be the -3, so it has to be the 2.5. So it takes 2.5 seconds for the rock to reach the ground. It takes 2.5 seconds for the rock to reach the ground. Because we know it can't go backwards in time, so it's not going to be the -3. So it takes 2.5 seconds for the rock to reach the ground. These are projectile problems where it's going to be a negative parabola, so it's going to open down because it's going up and then going back down.